3D printing community is providing a lot of mesh files, STL files, which are with very good quality. The problem is the CAD softwares are catching up to this trend really slow. It turns out that SOLIDWORKS already have pretty powerful tools to work with STL and mesh files. But because this is something very different, it turned out that people are really interested to learn how to use it. Me personally, I do present for this. I made a big series of videos in YouTube for STL, but still I learn a lot for these tools with the time I use them. This is my YouTube channel if you want to check it out. And now I will just move some screen around, start sharing my screen, and let's see, and start my presentation. You should see my first slide, correct?
Yes.
Okay, so today's topic is SOLIDWORKS Mastery, importing and proficiently working with STL files. More or less, I will show you all different ways you can import STL files in SOLIDWORKS, and I will give you information about the differences between these types of import, because the most important thing is what you need the STL file for. And when you know this, there is a different way you should import it. And a lot of people don't know this, and they try to import in the standard default way. And in this default way, a lot of STL files cannot be imported at all. So this is what you will learn in this session. A little bit about me. My name is Danute Petrova Nikola, also known as Dani. I'm a mechanical design engineer and owner of The Workshop. The Workshop is providing engineering services to different companies. So more or less, I develop products with them for the measurement industry mostly, where I have 11 years of experience, and I worked for automotive, electrical vehicles, aerospace, data transfer, and renewable energy storage, mostly for the first two. I'm also a content creator. I have my YouTube channel. I shared in the chat a link to it. And I'm also a user group leader to the workshop SWUG, which is the one, my group is kind of a bit international and local in Bulgaria. Mostly, actually, I'm presenting to different groups, but I do share also information when I have a new type of presentation in my user group too. And locally in Bulgarian schools, I'm going and teaching the students there some stuff. What you will learn: how to import STL model, how to repair imported STL model, and how to convert STL to features. On this screen, we see the 4 ways. I would say they're not exactly 4. Some of them had sub-ways in which you can import STL. The first 3, which is import as solid body or surface body, is the first one. Then after that is the same one, but with the option create mesh bodies enabled. And the third one is graphic body. These 3 are available with all versions of SOLIDWORKS. The fourth screen, which you scan to 3D, it's available only for SOLIDWORKS Professional and Premium. So you don't have this one with the basic SOLIDWORKS. And I think, yeah, most of the good mesh working features that you have in SOLIDWORKS are available after 2018. No matter that scan to 3D is included in 2010. So, how to open a STL file? The standard way is go on the menu where you have mesh files, and then you will have this option. Let me take a pointer. This options button, in which you can choose the different ways to import it. If you don't choose this menu here, it will still open your STL file in the standard way, but with the option that is saved in your SOLIDWORKS. If you want to import with Scan to 3D, then you should go to this menu here. If you don't choose this way to import a mesh or STL file, it will use the standard way. First way to import is solid or surface body, which were the first two options in your option screen. In this case, what you receive inside SOLIDWORKS is direct imported model. As you can see here, it's solid feature, not mesh body, but the problem is that every single facet is turned to a face. So you have this structure, which is with tons of lines. You receive a really heavy model. And it's a bit rough because you have every facet as a face. Sometimes it's not smooth as it should be. The positive is you can work directly with this one. And you can select points, you can select edges, you can select everything. But if the geometry is very complex, your SOLIDWORKS probably will hang, and even it can crash. There is a restriction, which I don't remember currently, but there were a few millions of facets that you can import in SOLIDWORKS. And it won't be able to import your model if it has more. But even if it's not more than this threshold that you have in SOLIDWORKS, this is really, really heavy model. So I would not recommend to use this kind of import for STL unless you literally need every facet as a face. A very rare cases would be in which you will need that, but still it's possible. I think mostly in simple geometries, you can use this kind of import. The second way of import is the one which I would say the most recommended. This is solid surface, solid body or surface body with create mesh enabled. In this case, what SOLIDWORKS is actually doing, it's importing your STL or mesh files as a mesh body, and then it's converting this to a surface or solid, depending on what is the model inside. But then inside SOLIDWORKS, you don't have imported geometry like in the previous model, you have imported mesh. When you have imported mesh, you can work with it, but faces cannot be selected, edges cannot be converted with convert entities, and facet lines are visible. And this is a bit annoying. To be honest, I have talked with the SOLIDWORKS R&D team, and I will remind them once again, if it's possible, just to remove these lines. They're sitting visually there, but they have no use. And they're just obstructing your view, as you can see on the picture that I have here. They're just unnecessary. What is good in this case, it's really lightweight model, it's really easy to import in SOLIDWORKS, and you still can work with it, it's editable. The problems like convert entities, you can have this work around and use intersection curve to convert entities, or choose the view you want, save as DXF, and then re-import, and you will still have the contour. This you can use also in different cases in which it's really hard to pick the contour, not only when you work with STLs. Just adjust the angle you want, save the view as the Excel file, and then you will be able to import this as a contour. I think that's one good tip. And the third way is actually to import it as a graphic body. That's a really interesting type of model that you can have inside SolidWorks. Graphic body is more or less like a 3D image inside your SolidWorks. You cannot interact with it. You can do nothing with it. It's extremely lightweight. And in the same time, you have complete visual of your file. And I would like to give an example here because I'm currently creating a 3D model of the port, ship port yard here in Burgas. There I have a lot of cranes. In my case, I use models, but I can also import STL as a graphic body and place it inside there. Because for the visual of the 3D model, you don't need the information that the 3D file brings. You have a huge area, which is a very heavy as a model to work with. And in this case, you can import additional details like a bush or a tree, just as a graphic body. Then you will have the image inside your file. It will look nice, it will look realistic, and in the same time, it will be without additional weight to your model, and it will be easy to work with. The other good thing is if you do have some troubles to import STL or mesh file in the standard way, you can always try to import graphic body, because with the mesh modeling tools, you can later convert this graphic body to mesh body, and this will be editable model. Then we have the very nice feature, which is Scan to 3D. As I said, this is available with Professional and Premium SolidWorks only, but this gives you a nice set of tools to work with mesh files. You have integrated automatic mesh repair tool. You have automated and guided process to convert your mesh models to features. In automated process, like this stone with a hole was converted, you receive directly a solid body at the end. When you use the guided process, you will receive a lot of surfaces, which you have to modify afterwards and create a solid body from, or just use them as a surface, depends what you need. And here as cons, I have written that it's not easy to work with complex models, but that's not exactly true, because as I said, with the time, I also evolve with these programs and these features. And it turns out that you can change and convert just part of your STL files and actually to work on pieces. And when you work on pieces, you can really work with very complex models and really bad scans. I think a lot of you have seen at least once a really bad scan, which has a lot of broken facets going in many different directions. With Scan to 3D, you can delete such shapes before going to the convert part of this. So this is a video that will show you how to repair with Scan to 3D. Here it's showing that there is some error in the faces. What I did is just to reduce the with 1 the size of the faces, and it showed the 2 holes. If you're going to the next step without changing anything, it will not repair your model. But when you're starting, and let me see if I can restart this one. At the beginning, it's showing when your mesh is with error. So when you see that your mesh is with error, and just on the question, do you want to reduce the facets? Just move a little bit slightly. So in this case, it will have to rebuild the model and will detect the errors. When it rebuilds the model and detects the error, on the next steps, it will automatically fix these errors. If you don't change anything, it will not fix your model. And this video will show you how to repair mesh body, which it's more manual process, really complex. If you try to use import diagnosis wizard, it won't work. As you can see here, we have a gap area. But what we can do is we can delete the face and then one by one build the facets or fill the gap completely, because you are not able to convert the entities, but as you can see, you can snap to the points of this imported mesh surface. And this is how you fix it. Depends how complex it is. You can do it in one or more than one steps. But yes, even without Scan to 3D, it's possible to fix damaged mesh file. It's not perfect, but it's working. And once you've knit it together, and you can create a solid from it. As you can see, at the end, we have two solids. Okay, and this is the moment in which I will ask if you have some questions, because, yeah, in a few minutes, I will show you directly in SOLIDWORKS some of the things with Scan to 3D and the imports.
When using Scan to 3D, like it works for all or only for a few of the errors? Like, let's say I have an importing error which says that the surfaces are overlapping or something like that. So in that case, how can I use Scan to 3D if I have Scan to 3D available?
It will work for all the errors that you have. It will automatically fix them, as I said, because this is the way it works. But it won't start repairing if you don't move something. You should just move a little bit something so it can detect, reshape. Oops, I'm sorry for the microphone. And then it will do it for you, for all the errors. Okay, so yeah, really powerful tool, as I said. I forgot to show my slide. Okay, so on this slide, I should have said that we will sit now in SOLIDWORKS. So as you can see in this case, on the left side, you have the STL file, and on the right side, you do have the feature. You can see also the imported body that you receive. And when I found about this, this is the automatic process. It's really amazing, because it's hardly other way to import in SOLIDWORKS STL file with an organic shape, and it looks correct. If you use the other way of import, body without mesh body enabled, there becomes the problem, because you will have all this like faces and you won't have it smooth as it should be. But also with the basic import with mesh body enabled, you can have it with a nice and smooth shape. Okay, so then And let's start the SolidWorks. And we will open, as I said, from this menu here. First, I will show you if you use the standard Mesh STL object, you should go to this menu to have the options. And here you choose solid body. In my case, my default is solid body with mesh body enabled. But usually what is default is like this. And that's why a lot of people say, okay, I cannot import STL. Yes, you can. You just have to come here and change your settings. And when I mark this, this is becoming grayed out. You should uncheck it to have the option graphic body. For now, I will leave it away because we do want to use scan to 3D. And here we have some other options which are nothing. So this is the file we want to use today. This nice knob, which actually I created for this tutorial, but I think it's a great example because you have a lot of complex shapes here. As you can see, in this case, there are no errors. And we have a nice mesh, which is sitting here with this yellow icon. So actually, I will just close it and I will open the same mesh file the other way. And as you can see, the icon here is completely different. Yes, you can work with this now as it is if you don't have professional or premium, but it will stay with these lines all the time and you cannot convert it to something else, which in some cases is not comfortable. For a lot of people, it will be more than enough anyway. So we're going again here. It's a funny story. For a very, very long time, I haven't used Scan to 3D because I didn't know how to open the files for Scan to 3D. I was thinking when I open STL and then I can use Scan to 3D, and I was seeing everything was grayed out. And I was wondering why this is happening. And then actually I did search in the internet and find that you should change the menu there to open it. And then you go to Tools and Scan to 3D, and you have this Mesh Preparation Wizard. It's asking you to choose the mesh cloud file you want to convert. I choose this one. First step is to change the orientation of your model. I would say don't do it from here. It turned out, especially with this knob, if I change the orientation from this screen, it's not translating the faces correctly afterwards. So better leave it like this, convert it, and move it afterwards. Don't use this screen here. This screen is the one in which you can choose what you want to delete, for example. And I didn't show this on 3D Experience World, but I will take the brush and will actually remove this internal area. And something interesting, I don't know if you know, but in this kind of selection, if you use Control and click, you will add to the selection. But in this case, by mistake, I pick a lot of faces that I don't want to be in my selection. And do you know how to remove them? It's really easy. It's Alt and click. And you remove the unneeded. This is another thing which I didn't know for a very long time how to do. And now when I have selected these faces, I will just, okay, I think I selected more faces than needed, but okay, I will leave it like this. Let's see if it will be able to repair that. In this case, I have open holes, so I don't need to reduce the amount. It will detect that there are a lot of holes. But on this step, you may want to smooth the boundaries. Just may. In this case, I won't because I deleted some additional faces, and let's see how it will repair it. Not very nice. So we are going back and going out actually of the mesh preparation wizard in this case. We'll start it again. That's why it's good before hitting delete to have a good look around if you haven't picked some of the faces. Sometimes for some faces or facets in this case, it's okay. It will be able to repair small holes. But here we're not talking about a small hole. It was a huge area that I deleted by mistake. And now it has selected again this area. That's why it wasn't able to repair it correctly. But now I will delete this once and just go further. And we can just stop here. We will have again the mesh with repairs that we did and just use it as a mesh. But let's assume we want to convert it. Then we either continue from mesh preparation wizard or you exit and start the surface wizard. We pick this one. And in this screen, you have the option to make automatic or guided creation. For this particular model, I can do it completely on guided creation. And where we need that when we don't need a split plane. When we have standard faces, which we can convert. On this step, we have a painting. It's dividing it on different faces. I think in this case, it's looking quite good. I will apply this one. This is individual. This is individual. That's okay. If for some reason it cannot divide it on the faces we want, like this one is too many colors, but I think it's still one and a common one, then later you can change it. Also by picking individually or painting literally individually. Like this is on 2 pieces, it's not a problem. Later I can pick both and to convert them. But if you want to do it manually, you just pick the color of one of them. And here you use I won't use the paintbrush, I will use this one. And it will just color it. Now let's see if this is in one. Okay, I think these are together now. So I will change them to be separate because it's not okay if they're together. Now, yes, now they're separate, which is okay. And this is the moment we can continue to the next step. Here we have a very nice button, which is extract all faces. This probably will work on something very simple. For me, it never worked. So I just click it for you to see it, but for me, it never ever worked. And from here on, you pick a face and you decide what you would like to happen with this one. As you can see, we have a planar, cylinder, cone, sphere, torus, extrude, revolve, rolled, and B-spline. For this one, actually, it's cylinder, so we will just make it the cylinder face. You have also some options. You have here the radius, you can adjust it. if you need to do so. If not, you just click somewhere away in the screen. It will convert this to a face and you can continue with the next one. If for some reason you made a mistake and you want to change some of the faces, or you have a trouble with your visibility, you have to pick it again. And this one I can change to revolve. It will make the same face, to be honest. But you can just do so. And also, you can select, right-click, and hide the face. So you can see what else you have to convert. As you can see, it's hiding not only the face, but it's also hiding the mesh it was created from. And now we have the interesting part. For this one, B-spline, for me, is the perfect way to do it. As you can see, it's making really, really nice face out of it. I just click somewhere away. I will hide this one too. Oh, it seems by mistake I exit my wizard. But that's not a big problem too. As you can see, the faces that we already converted are there, and we still have the meshes that we haven't converted, which is actually only this one. And for this one, I can start the mesh preparation, surface wizard again. It's not a problem. I will go again on the guided creation, split line if you have some. Sensitivity, no, that's one face. And in this case, the others are sitting on our way. So we can just hide them. Not from here. Here. Okay. So we take this one, and this is where I will use extrude. It's not perfect, but it's okay. And I will end also the surface wizard for this one. We take this one back. And that's all we have. What I want to do is to have this through all. And as you can see, this cylindrical surface is actually extruded. And I can go here and edit the feature, and I can add the second direction, and it will go through. There is still one mesh I didn't convert. It's sitting here, this submesh, but I don't care. I will just hide it. We don't lose our submeshes when we convert them. They're still here, and you can actually convert it second time. If for some reason you're not happy, I can just delete all these extracted surfaces, take out my submeshes again, and start over. And what we have to do now is to take all of this and knit it to one surface. So I go on trim. I pick Muto here and select all the faces. And what I'm going to do is to choose what I want to keep as faces. Let's see what we have. Okay. This I will need too. Now again, we're checking what we do have. Okay, the lower one we are missing. And this one. Yes, now I have everything. And how I know that I have everything? The option create solid is active. And here it is. That's our imported STL file, which we converted to SOLIDWORKS absolutely solid feature. We can do with this one whatever we want. Additionally, with this type of conversion, as I said, you can just check the sketches that you have. Like, I will fix this model and I can adjust it and make it fully defined. So you can do also this to fine-tune everything. Because this one, I may want it to be 6, for example, no matter that the original was something else, and I will have it. And I think that's really a cool feature of SOLIDWORKS. So now it's time for questions, if there are any.